Alright, and we are now live. Hello everyone, and welcome to today's Blender live stream, where today's project is going to be splitting branches. But, I have to warn you all, spoilers for Loki Season 2's finale. This is definitely related to that in a big way, and if you do not want to be spoiled, please do not watch the rest of this until you have seen the end result. It'll just be a visual thing, no like big spoilers, unless I start talking about it. No big spoilers on characters and stuff like that, just an end visual with the thing. So yes, keep that in mind while I get started on this project. So the main thing that I want to do here, I was deciding, should I make a kind of spiral curve for the branch that will then be splitting using physics simulations and all that cool stuff, or should I do it with a straight line? I think a curve will be better, because it'll just be more visually interesting. So let's get started on this one. I'm still deciding on whether or not I want this to be a simulation-based effect, or a more stable, non-physics-based effect. So let me just make sure that this looks good for more angles. Maybe I'll just use a curved spiral. I don't know, but the slight, imperfection with all of this, I think, is probably a good idea. Alright, it just got really bright in my room, so I need to close the curtain. The one downside with, well, the many downsides of daylight savings is that when it's 2 o'clock out, the sun goes directly through my window, directly into my eyes, which is not good. So I have to keep the blinds shut. Okay, so for this, here's the basic concept for this. Here, let me go and turn on this before we officially get started. Actually, I'm going to edit the title just to put in Loki spoilers, just in case. Potential Loki spoilers, yes. There we go. I'll just put that in there just in case. So the basic concept with all of this is that there will be a gradient running through the entire branch, and as it goes through, it splits the branch. There will be 2 branches in here, and then they will split according to a gradient. Both parts of the curve, once they're duplicated, will move in opposite directions of the curve normal. So I will try to get that started. If you cannot tell, I am coming up with the method for this on the fly. So let me start this out. So the main thing is we are going to duplicate elements. In this case, it will be the spline, so that we have 2 of them. And then the one that has the duplicate index, we will mark that one, the second copy. So for that, I will use a store named attribute node. And this I will just have as... We can have this be a Boolean vector because the duplicate index, it'll be 0 for the first and then 1 for the second. Which means that this will be 0 on the first, 1 for... Yeah, that'll work. That'll work as a Boolean value. So this will be is duplicate. Because technically they should have the same data, because they're duplicates, except for the index. I think those get stacked on top of each other. But yeah, I think that should be good. So now that we have this stored, we now know we can now split them. We can take the normal and say, hey, take the normal of that curve as a force moving the curve, but for the other one, split it in the complete opposite direction. So yeah, and then the other thing that we need is an attribute for our force, for the gradient that kind of, I'm thinking like, again, spoilers for Loki, but there's like a green pulse that runs through the branch, and that splits the branch. So yeah, it'll be just a pulse of, just a standard gradient going through there, and when that happens, the force will be applied to the curve, splitting it in 2. And the thing is, this won't happen only once. The branches will split but then these other branches will start splitting as well. So this could go exponential, which I have to put in a failsafe for. But we'll get this started. Let's have a gradient. This will probably be remade a few times, but the logic is there. So let me go and turn on snapping, because that is always very, very necessary. Okay. The thing I never stood is why is everything made of string. Time branches, in a kind of literal sense. Artistic license, as they like to call it. Yeah, a visual representation of the branches. Okay, so for here I'm just going to take the spline parameter, get the factor, and then I will need to use a color. This is going to be interesting. I'm going to use a color ramp, like this. So here, let's use the viewer to showcase this. Here we have that gradient, but I want it to be way more compressed. Just like this. And, okay. One thing that I did not take into account is that we have to resample the curve so that all of these are actually realized. Let's set this to be evaluated. Okay, that'll be good. That just makes it so that instead of the control points being the only places where data is stored, which is probably more efficient, but for this we need all the points to actually exist and have data be stored on them, not just the visual end result. Okay, so now that we have this, that's like that. And then we just need a cycling time thing. So the gradient goes from -1 to +1, or +1 to -1. Or I'll just put that as a subtract. So let's have a map range so that every second it'll go from -1 to 1, and we should see, there we go, that happens. I don't want it to happen quite that fast. So, let me think about this. I could use a wrap node, and that would probably be better, or a fraction node. So this will make it so that it happens every second. But I don't want it to happen this fast. So which method do I choose? I can just divide it, and then fraction it. That'll mean... Yeah, that should work. As much as yeah, a little bit clunky with the map range, but that should be fine. So there we go. This will be move gradient. Whoops, and my spelling is completely on point at the moment. So this will just be move the gradient. Lovely. Let's go and put this over to here. This is our gradient. Oops, and I am spelling that completely wrong. It's a little bit cold in my room at the moment, and whenever it's kind of cold, my hands cannot type nearly as well. So please excuse my poor typing skills. This will be split branches. Yeah. Yeah, that's good enough. Alright, so now that we have that, we can start with the simulation parts. So this, I just want to get the physics right, just to test it. Because right now, let me just set up an example to show what we've just done. So I need the named attribute gradient, the named attribute is duplicate, which is a boolean, and another attribute, which is technically named, but you need to reference it with the actual node, the normal. So here with the normal, we only want to scale this according to the gradient, but we also want to invert this if it's a duplicate. So here, I'll just put in a switch node. So that will switch between the normal mode and the one that is scaled by -1 by the isDuplicate attribute that we stored. So the logic is very, very clear. There we go. So now if we hook this up into here, we should see, there we go. These are now splitting according to that. It's a little bit strong, not gonna lie. So I can tone that down, but the theory is that with this little piece of logic here, the physics will take it from there. I hope. It should work. But there is the basic logic behind it. And I could just put this here to show the flow of data a little bit better. And then, again, I could scale after the fact, but we're going to replace the physical offset with a simulation offset. Or, yeah, we'll make it simulation-based instead of whatever this is. So let us set up that simulation, which basically means I have to make rope physics once again, which will be very, very fun, I assure you. So let's put this into here. We just want this and that. Let me save this in its current state, just in case we have any unscheduled crashes. I am using Blender 4.1, just because I might use the repeat zone. Not entirely sure. So set position. Yes, I need to remember that. Named attribute. Let me read the chat really quickly, after I put in the velocity attribute. Yeah, I should spell out the full name of it. I would usually spell it Vel, but having the full name is probably better. Less hacky. So now I will show you the completely broken version of this. Let me scale this down by quite a bit. This will just move the mesh where it's supposed to go with velocity, but the velocity will never stop. Okay, that's a little bit unfortunate. I forgot to put that after the simulation. Because the mesh right here gets frozen when it gets put into a simulation zone. So that means to get the live value of this, it needs to be inside of the zone. There we go. So there we go. Now we have it so that they are splitting. A few things to note. I do not want it so that the beginning splits like that. Not great. Not a good idea. I want it so that those stay rather steady in their kind of root position, shall we say, which I may have to store that. We will see. But now that we have that, at least partially up and running, let me go and put that into a frame. Should be good. So now should I pin the ends? I think we can do that. Okay, so I'm going to use a mix node to pin the start of it according to the spline parameter. In this case, it will be the factor. And then we shall use a color ramp. There we go. Plug it into there. Plug it into there. So this means that the parts that are... Okay, I had it on the exact opposite way. I should probably make it so that white is good, black will not move. So there we go. Now we basically have it. Interesting. Oh, I understand. I understand. If I use a power node, that might make it a little bit better. We will see about that. No, that makes it like 10 times worse. Because since this is kind of exponential, when it's 0, it'll just keep moving, but if it's the tiniest amount, it will stop. Which I'm not sure if I actually want that. Yeah. I'll have to think about that, but since we have the ends actually pinned, let me put this into a frame. Very elegant. Very, very elegant. Since we have that, it's now time for me to at least attempt to put in the rope constraints. Now, do I do that before or after the pinning? I'm going to assume before, just in case. So this will be split force. Yeah, there we go. So to split these, we need to do a little bit of fun stuff, which is... Ooh, to make this accurate, we need to store the original curve vectors and then compare to that. Or I could do the cheap method, where I try to make all of this equidistant from each other. So what we need to do is take the position and the blurred position, the interpolated position, so that this will look at, this vertice will look at this, or wait a minute. No, it should work just fine. It'll take into account basically how far it, wait, maybe I can pioneer a new method of this. Instead of taking the blurred attribute, maybe I just take the position of the previous one in the list, the previous one in the fold, and then try going to there, because the blur blurs the front and the back, which might be a little bit inaccurate, so maybe I just do the back and then they'll all just work eventually? Not entirely sure. But if we subtract these two and then put this into here, we should see, okay, and plug these in the exact opposite way so that we don't have that weird stuff going on. We should see that those are trying to collapse in on themselves with their elastic nature. That is actually working. Now, as you can probably imagine, we don't want it doing this exactly. So that happens, and then the split force happens. So we need to normalize this and then get the length, modify the length, then rescale the vector by that so that once it gets to be too small, it'll apply a negative force, moving it back out, and then when it gets too far, it'll move it back in, and so on. If you didn't get all of that, you don't really need to. Just follow along with the nodes. We're basically, right now, the force is trying to take two dots on the spline, like these two vertices, and move them towards the center, or more accurately in this case, the center of this and this, which is probably inaccurate. What I'm going to try to do is say, hey, if you get too close, move away. That's what this is going to do. So if I subtract by 0.5, the target area where it will probably try to go is 0.5. But I have not thoroughly tested this, so this may lead to a disaster. Another thing that I should mention is that these should probably have a distance of 0.05. So here we should see it is, wow, okay, that was unexpected. It is working pretty much first try. Now, this still may be a little bit inaccurate. Like, one thing I do not understand. Oh, I know why it's happening. All of these points have a slightly different length to them, but if I were to go into here, there are two ways that I can fix this. I could either make it so that all of them are a set point away from each other, like that. Actually, twice the length because of the two vertices problem. And then make it so that the cache has to restart. Interesting. 0.2. Still a little bit of an error, so I may have to do the other method, just to be sure. I'll have to think about that. But it is semi-working at this point in time. So another thing that we must do, for more accuracy, we should add the position with the current velocity into the fold to make that work. And we need to also blur the velocity so that the other parts of the branch are affected by that. Not just the elasticity, but the velocity also transfers and all that good stuff. I know I'm going fast, but that's just because I want to try out everything I can in the limited amount of time I have with this. So this will be rope physics. Elasticity, yeah. Elasticity. Yep, I think that's how you spell it. So, that should be okay. I'm still not very happy with the pinning here. Oh, dang. Oh, wait a minute. Yeah, there's a good chance I screwed things up with the distancing for all that. But they are splitting, so that is a plus. So another thing that I plan on doing in the future is actually splitting these over and over and over again. Which, oddly enough, I don't think will be that much more difficult to do. I just need to do it correctly. So, I will... Should I try that next, or should I fix our little issue here? Let me split the branches, and then I can fix the other stuff. Let's just get this functioning, bug fixing later. Let me save this as well. So what I'm going to do next is make it so that the splitting will happen once every 2 seconds, like I have here, so that as soon as the cycle goes through, it'll split again so that it is seamless, and then the pulse will go through again, splitting those branches again, and again, and again, and again, until the end of time. But there is just one little problem. Stuff like this will go into infinity, which may or may not crash my computer, because it will be going up exponentially, doubling every single time. So I need to build into this a failsafe. I could do this probably before the simulation output, just so that everything is good. So I'm just going to use a delete geometry. I'm going to set this to spline. And then I will use a domain size node. Let's set it to the curve thing, and we will do point count. If the point count gets to be too many, let's say greater than, and let's do 250,000. That seems like a good number. It will delete everything. So it will kill the entire simulation if the number becomes way too big to handle. So just a little safeguard. Little failsafe. Again, tying it back to the Loki show. Alright. Yeah, oh wait, that's actually what I'm doing! If there are too many branches, I just wipe them. I've made my own temporal loom, I guess. Except this eliminates everything except the ones that are too great. I guess I could do that. I could say, hey, if your index... But that wouldn't be... If your index is greater than this amount, then just delete yourself. I'll do this just so that we can clearly see once it goes too far. So this will be fail safe. So if this fails in the way that we get too many points, it will just fail and we will be safe. My computer will be safe. Okay, that sounds good. This will be pin ends. So this, again, is the risky part. So let's prepare. I'm not entirely... Oh, and also, let's just blur the velocity. This will give us some somewhat better results. I'll set it to 0.5. So, and we also may want to add in some drag, but I think the pin ends has that covered for the time being. So we don't need to worry about that. This will be old velocity, and man, my typing is not up to par today. Okay, so now that we have this, I think we should probably expand this so that we don't have the spaghetti going everywhere. So, yeah, that should probably... Oof, as much as I don't like big node trees, I try to compact things as much as possible. With this, it is very, very much necessary. I'll just put these here and here. This will be apply velocity. Keep forgetting about that one. And I did the spelling right that time, but I forgot the caps. There we go. Let's save this once again. So, oh, this is the difficult part. Or is it? So I could do this in two ways. I can have an age attribute on every one of the branches, so that once it hits like 20, it will repeat, or I can just use the frame range, and then that'll work. I think, yes, let's set this by frame, so that I can say, hey, this will work every like... Oh, and this is not in 30 frames per second, I forgot. Let's have a nice even number. So here, let's switch that to 60, which will be every 2 seconds. And now I need to say, hey, if you want frame 1 or frame 0, I forget which happens first, then split the branches. Or in this case, swap it from duplicating it once, which is just keeping the first one, and swap to the one with 2 duplicates. That would work, or I could just use a switch node to switch between the duplicate path or the original path. Let's do the switch node just for clarification. So here I will decommission that part for the time being. And now I will implement that switch node. If it splits, it will switch to the one where it duplicates, and we should be in the clear. Now, it's not referencing the spline's actual time, it's viewing the global time. So we should be in the clear. So if this value is equal to, let's make this an integer. We should be in the clear, I hope. Is equal to 0, then it splits. No. Set it to 1. I truly... Oh. We need the wrapped node. Yes, okay, uh-oh. Is the stream going down? No, it's fine. Just a little hint of lag. So, instead of that, we need to handle this just a little bit differently. So we need to use the wrapped node because I want this to be a very good integer value. So we need the same value input for both of these. This so that... Actually, wait a minute. So this divides the frame value. Instead of between 0 and 60, where it goes 0, 1, 2, 3, 4, 5, 6, to 60, this makes it so that it goes 0 to 1. That's fed into our fraction, which is then fed into our map range. If we use the wrapped node, it will loop it around, but it will keep the big values, so 0, 1, 2, 3, 4, 10, 20, 30, 60. So if we do this, it should work, but I should probably find a more elegant solution for this. I guess I could just put this into here and then put in the value to both there, and that should work as intended. So I would just need to plug the same value into there and into there. I think that's the most elegant solution, even though it's not quite that elegant. So I will use an integer as an input. I'll plug this into both there and there. Set this to 60, and if I play this, it should be functional. It works. There we go. They will keep splitting until the end of time. So another thing that I would like to do is make it so that the branches actually look more like branches. So the question I have in my head is, how do we do that? How do we do that? Well, I could make it so that instead of a pinning value like we have currently here... Actually, I need to think about this. The split force will only happen either in the middle part on the first pass, and then on the second pass it will happen a bit less, and then on the third pass it will happen on less of the curve and less and less and less every single time. But that means that I need to count how many splits we have done. Fortunately, that's pretty easy. We just need to have an integer, which is just 0, 1, 2, 3, 4, and so on. We can have this on the spline domain because, oh, we can have both of these on the spline domain because that makes it faster. It means it only has to calculate once when it's stored instead of on every single point on the curve. I am doing a little bit smart stuff. Are there ever any elegant solutions in 3D? Yes, there are. They are just very, very rare. Okay, so here I'm going to do split count. And, of course, I spelled it. Dang. Split count for here. So every time it goes through this path, the split path, it'll add 1 to this value. There we go. So it will do that, which is making the split part just a wee bit bigger, not too much. But now since we have that, we can make it so that the split amount only affects less, or only affects a little bit of the curve, and that amount becomes less and less the more splits that happen. I think we're on the right path. I think we are on the correct path. I could put this in there just to... So far, it's not the worst in terms of organization. Even though we sample curve... Sorry, I'm thinking so much about the algorithm that everything else is just going out the window. There's only so much space in my brain. Okay, so we basically need to have a pinning value, but instead of a pinning value, it just multiplies the split force by 0. So that with that gradient, actually, I can showcase this. Here, let's go and watch our split force value. Dang, that is a very small value. It's not even appearing. Okay, let's go and redo. There we go. Okay, we can barely see it, but you can see it going through. Kind of. Alright, let's go and make sure that this is still working as intended. Oh, right, I multiplied that by so little. Okay, that's why. Okay, let's take a look at this again. Okay, that's much better. So here we're seeing the end result. Very cool, very nice. So here, again, we're just taking a curve and splitting it again and again and again according to that gradient. I am so glad that the viewer node works on curves. The unfortunate thing is it does not work on edges, which is very, very annoying. I think that may be because edges are always a part of a mesh. But then, no, I do wish if it were on the edge domain, it would apply the same viewing tech as the curves. Maybe I can suggest that to the developers? I do not know. Okay, let's set up the... Okay, let's think about this again. Okay, yep, I know what to do. I need to take our curve parameter, invert it, then divide it exponentially by our split counter. And then I need to reinvert that and then apply this to this scale. This should work. So let's use a map range value. We need to invert this, so that's just 1 and 1. We could also do this with the multiply add node, but just for simplicity's sake, I will not. We need to use a divide node to divide this by the split counter. And then we need to set this to the power of 2, so that the value becomes divide by 2, divide by 4, divide by 8, divide by 16, divide by 32, divide by 64. So there we go, we now have that, and now I shall use a color ramp to possibly reinvert it. Let's see if that is necessary. And also, I do not like the new... Well, actually, no, in that case, I think the new search might have done well. I think that might have been accurate. So here, I will turn off the pin end, just to make sure that everything is working as I intended. Okay, wait, actually, let me flip this around. Okay, I think it's time we need that viewer node so that we can see everything that's happening. The viewer node is extremely good. Oh, that's why. That is why. So here it's getting divided. Wait, did we not even... Oh, we didn't even need to... Wait. We didn't even need to invert the first pass? I am... Nope, that makes... No, that doesn't make sense. No, this part should be inverted. Set that to the power of 2. So that happens. Wait, let me double check this. So that when that gets divided, that happens. So that if we have that, then we invert it, we should see that once this divides... Okay, no, we want to multiply it. There we go. Simply the wrong operation, and there we go. The gradient is getting halved every single time. So this should be good. Let's take a look at this. Let's see. Gradient... End gradient divided by... Or end gradient halved. By split count. There we go. Self-explanatory? Maybe not, but should be good enough. There we go, we're getting it. Let's extend. Yes! Yes! It's working! Oh, that is beautiful. Ah, that's good. Seeing it finally come together a little bit. Now, the slight unfortunate thing is that this isn't accurate to what happens in the show. Loki combines the branches in the finale to a degree. But I thought this would, one, be more doable in geometry nodes, and be cooler. So we have this, now it's time to make it look better. Our current issue is that, well, the splines are just floating off. They are completely forgetting about their constraints. They should be collapsing in on themselves a bit more. They should stay the same length while still moving, like that. So if we do this, what I do not understand, here, let me make it so that they have to go, oh, there we go. So, okay, yep. Now they're trying to shrink into nothingness. So maybe that value was just way, way, way too big. Yes, indeed it was. Wow, that is... Oh, that's cool. And maybe... Oh yeah, I could do that as well! I can make it so that the splitting amount takes the same amount of time for the gradient. Oh, yes, I can do that. I can do that. Alright, so it looks like the only thing that I really need to fix is the elasticity, which I do have a new algorithm in my brain for. So, yeah. Oh, that is beautiful. Now, what would be really amazing if we got to see some of our values here as they go along. So let's do that. Let's take that, except I'm going to multiply it. Absolute it. Now let's multiply it by 100 so that we can actually see what's going on. So, no. 1,000. Let's make it bright. There we go. So here, well, it doesn't really look that impressive after the scaling, now does it? Here, let's multiply by 10. Okay, so here we go. Okay, let's restart it. Now, this is cool in and of itself. Here, let's watch it in full screen, and also save this. As the gradient goes through, we're seeing that the branching is still happening again, and again, and again. So now, all I kind of need to do, essentially, is get the shader up and running, and the effect is kind of done. That is getting very intimidating very fast. But I love it. Oh, and then the failsafe worked. It worked. Wow, I was like, wait, why is it deleting? Well, the failsafe is doing its job. So, while the animation is playing and looking very cool, if I do say so myself, now the problem still is that, too big. I'm gonna fix that. Let me read the chat. Okay. It's a scaling problem, haha. I understood that reference. You have paid tutorial? No, I do not. Do you have your own Discord server? I do, but it is essentially dead. So one more thing, I'm going to let this go to 1 million. Which means that will only go for 2 more splits after it originally would, but just for fun. Yes, I have a Discord server. The last time I used it was for the 50k subscriber special live stream. But yeah, I don't really use it often. That is, wow. Okay, no. We are going further beyond. We are going to 10 million. Which, you may think that's a bit much. I've dealt with worse. Okay, let's let it play again. Okay. Is the new Loki season worth watching? It is. I think it might be better than the first. Like, the finale, it's really good. It's really good. I would recommend it. I don't think I like how you would run the TVA. What makes you say that? I don't see it. Okay. Yes, keep going. We're at 6 frames per second. Yes, keep moving. We're at 3 frames per second. Keep going. You can do it. You can. Just split one more time. And failsafe. Nope, I think it's split again. It's split again. We're at 1.5 frames per second. This is almost as slow as your average Eevee render, which is very odd to say for a real-time engine. There we go. It's still going. Uh-oh. Oh, no. It's lagging my computer. Retreat, retreat, retreat. Stop it, stop it, stop it. Okay. I think the failsafe worked. Oh no, we just hit the end of the frame range. Okay. My audio started glitching out from the lag, so, yeah. Which means that the stream probably had a hard time with that as well. Okay, there we go. Oh, yep, now we're back to the chat. Up to date with the chat. So, I still have the pinning happening, which I'm okay with. Now, it seems like the only thing that I need to actually fix is the scaling issue. So, yeah. And then I need to mesh the curves at the output, which will make this really, really laggy. Even though I do have a if I try to use the hair tools in Blender, the curve tools, it automatically creates a GPU hair strand on those. But the radius cannot be dynamically affected by geometry nodes. It's only like the average overall of them. I made a bug report about it, but apparently it's been a known issue for like 2 years plus, because Eevee for some reason can't do it, even though it's possible for real-time engines to do it. It's a piece of cake in most of them. So I'm assuming that the fix was probably scheduled for Eevee Next, but since Eevee Next got delayed like 2 years at this point, 1 year and 9 months I believe we're at, I don't think that will be coming anytime soon. So we have to deal with what we have. That is beautiful. Okay, let's fix the scaling issue with, well, I'm going to save this version because I actually do like how it looks. So I'm going to store named attribute, and we need to, 1, store the curve vectors, potentially, and the parent index. The index of the vertice before the current vertice of the curve. So to do that, we need to get the offset point on curve node, just like this. We need to set this to, I believe, -1. I may need to double check on that. And then we need to use a switch node to say, hey, if the point index is not valid, then switch to the original index, which will be like its start point's own index. And I should probably put this in here just in case. Little fails. Well, with these nodes, if you have a node in front of it that's like, oh, evaluate on spline or such, it will change how this node works, which was very confusing to figure out. That's how it works. So with this, we get the parent ID. And with that, we can get the distance to the parent, which means that we can get the length to the parent, which means that we can take every curve segment and say, hey, are you at your right length from your parent? And if not, try to go there. So, let's set that up. We need to evaluate at index. Let's change this to a integer, because that's how it should work. Plug that into here. So that is currently the parent location, but we don't want that. We want the parent vectors, which will give us the orientation, which I might need. But from that, we can extrapolate the length. So I'm just going to store the original curve vectors. So vectors O for the original curve vectors. C vectors O for our curve vectors original. Now I'll just label it, vectors parent original. That's good enough. Parent off? Nah, it's straightforward enough. So if we do that, we store the original curve vectors, which I should probably label. Yes, I need to make sure I keep up with my naming conventions and such. Oops, sorry. I need to double check that these are in the right orientation, or else it will make them go in the exact opposite direction. Yeah, I should probably make those like node groups so that I never have to look at them again, or remake them every single time. Vectors, there we go. Here we have the parent index. And caps, 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 caps. There we go. So now that we have this, we can extrapolate the length from there. But we need to, with the elasticity force, we need to compare the original curve vector length to the current one. And then we use that to say, should we... Wait, I'm currently thinking, sorry. Just double checking. Okay, yep. That, yep. Yep. Sorry, I'm doing a lot of, like, calculations in my brain, which you all are not inside my head. So, where are the vectors? Oh, I need to restart the cache so that those are recalculated. You're not inside my head, so a lot of this is probably going way too fast for anyone to copy, and I apologize for that. But I need to think very fast because we are at 46 minutes. And I only want to work on this effect for an hour, maybe an hour and a half. So if we do this, as we can see, it is working beautifully. Okay, we may need to absolute that, but oh god. Okay. So I think we may need to... Oh, dang. Yeah, how do I do this again? Oh, okay. Yep. I need to compare... No, but I'm already doing that. I'm comparing the lengths between the two. And if they're more, the force becomes less. And if not, the force becomes... But that's trying to go to... That's trying to go to there. It's not inverted. We already tried that. We can see it works, and then that happens, and then it just really freaks out. I'm forgetting something absolutely crucial with this. Do we need to also... Wait, was the previous elastic force the way it was supposed to be? Do I need to absolute the vector value? I think that may be the case. But I'm not sure. No. So right here, it's trying to go towards the parent index. And the amount it should want to go to its parent index should be the differences in the lengths between those. But I think the issue is... that might need to be a dot product. No, it doesn't. The previous method with the other thing, it was serviceable enough, but not accurate enough. Though, to be fair, I could just re-implement it. And then just use the length of the original vectors, but then double them. Which means that it should be mostly accurate, but it won't be completely accurate, so I'm still confused about that. So this should mean... should at least try. Like, it's inaccurate. Because we have that pinning force, the inaccuracies just stop. But there they have more room to expand. So I either need to divide this by 2. Or multiply. Whoa. Dang. Well, that was a bit unexpected. Divided by 2, divided by 4, set it to the power of 2? Which is it? Like, what we're supposed to be doing is comparing the current length to the old length, which should be functioning as intended. The only thing that should be working wrong with this is that the distances are not good enough. Because with the averaging, it's averaging both sides, so the distance is assumed to be doubled, but it's not guaranteed to be doubled, because the length between the... Oh. Oh. Okay, if I want to switch it to the elastic force, then I need to put that into there. Which means that now... it should be mostly fine. It is not mostly fine. No, it is going back. It's just very, very lethargic in doing so. Which, another thing that I should mention is that I would need to apply the elasticity force with the velocity added to the position in order to make it actually work. As we can see, it is working. Just not well enough. Because that's happening. It should not move whatsoever on the first little pass. I could try using an accumulate field node to accumulate the vectors, but just change the orientation to the orientation that was in the other one, which may cause velocities to go wacko mode, but it might work. So let's have the parent ID again. I'm pretty sure, yes, that should be correct. The parent ID does seem to be correct. The original vectors seem to be good, maybe inverted. I'll have to double check on that. And then for you, here we have the offset to the parent, the curve vectors. Offset to parent. Offset to parent, comparing that to the original parent offset. Though they technically mean the same thing, but here, maybe that'll be a little more explanatory. So I'm confused as to why the rope physics are freaking out in that way. I'm still wondering if this is inverted. Or maybe both of them are inverted? So if both of them are inverted, well, okay. Oh, alright. But if both of them are inverted, then that should mean that none of them are. But maybe... Come on, we can do it. Here, let me try doing this one to see if anything... Nope. Actually, that was pretty cool. Was it good? No. Was it cool? Yes. Alright. Okay, if we start getting locked up here, I'm just going to keep it with the elastic force. And then I'll get to the shading, because we are at 55. Yeah, okay. I'll figure out the proper elastic force sometime. But for now, let's just keep it as is. What if I set this to negative? Okay, they will try to collapse in on themselves. They are trying that. So I guess the one accuracy that I will make is that the velocity will be accounted for, which won't make this perfect, but it'll make it... Like, with the elastic force, you need to go through quite a few iterations to make it accurate. So I would need a repeat zone and then boom, 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 like 10 times in order to make it work. That great sound effects right there. But here I just need to add the velocity to the position and then feed it into the curve vectors to make sure that they are accurate. With that being said, and I would have to do the same with the offset to parent. I would need to make this parent position that as well, but I'm not going to worry about that until I actually fix that. So here, this should mean that if there is a high rate of speed, it will try to compensate quite a bit better. So they shouldn't float off as much as before. But that, I'm just going to save that for later. I'll figure that out off stream. So yeah, yeah, so that's how you get the vectors right. I should make that a node group just to make it easier on myself, on my eyes and all that. But here we are. So here we go to the curve rendering side. So there are a few cool things that we can do. The one thing is that with the curve, the fur object, the hair objects. Okay, let me add in a fur object just to showcase what I mean real quick. Oh, I do not like these nodes because they are so heavy when I'm not sure they should be. I've done a lot of testing with them, and I've found that a lot of them are way too heavy for their worth. For what? In some scenarios. In some scenarios, like, it just needs to be that heavy, but especially compared to the old hair system, interpolating hair curves was not that bad. Okay, let's set it to strip. If we set it to that, then all of these, as we can see, have actual segments tied to them. These are all drawn on the GPU, so it's very, very fast compared to converting the mesh, the curve to mesh, which is realizing everything, which is really eh. The weird thing here is that the radius for all of these are actually accurate. They're not accurate, they're all copying the same pattern, which is a current limitation with Eevee and the Workbench engine, the viewport, and all that. It's just a bug that they couldn't find out how to do it right. So these cannot have varying radiuses. But for speed, maybe that's okay. It would be nice to make a very nice threaded cable for all of the time branches, but yeah. So I'm just going to add in a plane and then an empty hair node because you have to have these attached to a plane, which is very odd. Like, the hair system, I do not get the most of the logic behind it, because to make an empty hair, you have to bind it to an object, even though there's not really an accurate workflow. And then it'll add it feels like an add-on. You click on something, and then it binds itself to the object, adds in some data, and then adds in a geometry node group with a black box node. I'm just not the biggest fan of it. But what I want to do is just eliminate this, eliminate the parent, eliminate this parent so that we just have the empty curve object. And then I'm going to have a new well, actually, I'll use that, I'll use a new geometry node because I'm just going to reference the curve, because the only thing I actually want to harvest from this is the curve rendering, which is very funny. I only want to harvest the very fast curve rendering. So I'm going to, wait a minute. Why is that so small? Well, I'll use a resample curve node because I'm just going to assume that that's a quirk of it. I'll make this be, what? Man, this is quirky. Resample curve? That spline type? Interesting, I've not run into this before. Huh. That's really weird. I could just have the simulation on the original object, but I don't want to alter that for an experimental side thing to figure out the rendering. So yeah, that's really freaking weird. Oh, wait, and I also had that there, so even if I did have something that actually worked, I would not be able to realize it. So flickering through all those, just, wow, that is, why would it resample it to 10? It's referencing another object, it should be perfect. As instance. Okay, so that works. Now I should be able to just realize the instances. Dang it. Resample the curve beforehand. Yeah, I shouldn't be. Yeah. I'm assuming because the original curve is on the Bezier curve space, the original data for this, like the preview resolution, is affecting it. I'm just going to assume. Go out on a limb. So if we do that, now it matches. And now it matches. For some reason, it just decides... Oh, that might have been one of the optimizations the devs were talking about. Okay. So, wow, that's weird. I can't override it. That is not great. I think that might just be a rendering issue. Nope. Still an issue. Dang it. Nope. Nope, 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 nope. Let's set that back to 12. Okay, so I do not know what's going on with that one. So let's do this the manual way. Let's just have a nice smash. Let's just go through the methods that we know works, not the sketchy curve method. Let's take the Bezier curve, bring it into here. And now what I want to do is make a kind of braided cable. Now how do we do this? Well, the way we will do this is use a duplicate elements node. We are going to set this to a spline. And with that spline, we are going to offset it based on not only the duplicate index, but also the normal in a sine wave. So here, let's get the length, the curve parameter. We could either use the factor or the length. Let's go and use a set position node. Set position. There we go. We're doing this the normal route. Like normal people. The slow route, but the normal route. Optimizations can be done after. So now I'm going to use a sine wave, and I'm going to multiply that by the curve normal. There we go. Whoops. This should be a scale node because that is faster. And it actually can handle the right data types. So here we can see that the sine doesn't look to be working, but we just need to multiply this so that it's like that. Very nice. Let's multiply it by 100. Actually, better yet, let's have it be by the length, so that no matter how big the curve becomes, it'll be pretty much accurate. Something's off. Why is the... Please don't tell me I broke the sim. I think I might have broke the sim. Oh god. What'd I break? This better not be just geometry nodes being funky, especially with that curve weirdness. Okay, no, it's good. Okay, the cache just needed to reset after the weirdness. Okay, so here we are. Let me go and scale this by a bit less. 0.1. So now let's have this be, yes, a lot more like that. Let me resample the curve so that we have even more resolution. Let's set it to like, I don't know. Oh wow, it was less than 500? Interesting. So now that we have this, we need to offset our sine wave, the gradient here, the length, by a random value. Fortunately, since we have the duplicate index, we can have this be a random values input, the ID. So if we do that, we can just go and add this to the length. Let's set this to something like 1000, which means that now we have something like this happening, which is looking a lot more like a braided cable. Now, with the other things that we have to do, let's just go and set this up to be a little bit better. Now, should I store the duplicate thing there? Probably. Is it fine as is? Yeah, I think so. I can have a random scale for this one by simply using a random value, then using an evaluate on domain node, set it on the spline, which means that calculates only once per spline, but then the points read it, so it gets a little bit muddy, but you get what I mean. So there we go. Now we have something like that. But the problem is, that's funny. You can tell we're past an hour, so that's where my brain starts to have a more difficult time with all this, which is why I like keeping my streams under an hour. My brain just starts to fry from all the math that we are doing. I found with other projects, like, at least on stream, off stream, it's the rules are kind of similar, but I think because I don't need to explain everything, my brain is a little more relaxed with all that. That after I go past an hour or two, there's like diminishing returns with the math that I do. The quality is less. I get more confused because my brain is just not seeing everything with the right perspective. Okay, so little tiny issue there. When the duplicates happen, we see that happening. I could just store the original spline IDs, and then we wouldn't have that little jump, but I'm assuming that these will be small enough so that that won't be an issue. Okay, so another thing that we have to do is that we need to rotate our normal vector so that this won't be a flat plane, so that's actually rotated. So to do that, that should be fairly simple. We could do that basically anywhere. We could put the rotate at the normal, we can do it after the scaling, we can do it after here, so I'm just going to do it there because the thing fits. I will use a vector rotate node, not the new one, because that one, the new rotation nodes still seem to be a little weird, because Euler rotations are just labeled as rotations, and quaternion rotations are also set as rotations, not quotations. So the naming convention is weird and a little bit convoluted. The only way to differentiate it is with the color, which is a little bit weird. So let's get the vector rotate node and the regular rotate node. Rotate vector node. So we have these two, but if we set them both to Euler, we have rotation and rotation. Both of them have 3 channels, even though quaternions have 4 channels. So for some reason, they can't display the actual data here. So these are both the same, but internally, these are handled as quaternions. The only differentiating thing about this is that the socket is that. I feel like these nodes got rather underbaked because this should be a quaternion inputs. Even though there could be a... Maybe I should stop going on tangents about weird geometry node quirks. Because here we can do... rotation to quaternion, which this will turn a quaternion input, which is Euler. That doesn't make much sense. And then it'll output the actual data of the quaternion. And then we can also have a rotation quaternion to rotation. So this converts it into a purple output, but the purple is different than that. The purple should have 4, if I'm correct, or maybe I'm just very, very on the wrong path. But either way, yeah, just be aware that it's a quirk. I think that might be updated later. But, yeah. Okay, so let's set this to axis angle. This could be done with the new rotation nodes, but I don't want to touch those. So I need to use the curve tangent as the rotation axis. Why did that do that? Tangent? Wait, why would tangent lead to geometry to instance? Second. Oh, TAN. Oh, okay. Wait a minute. So it reads... Oh, okay. So here we can rotate it along the tangential axis, which means that if we get another random value on the spline domain, the evaluate on domain, let's put on the spline one. And this does make it a lot easier for it to calculate because it only operates once per spline, and then it does have to convert to be per point, but it's okay. So here we have those all being rotated as intended, but we may want these to spiral. So Actually, do we even need the sign in this case? Because here we have something like this, the actual paths. But if I keep rotating this angle and then make it like clockwise and counterclockwise and spiral according to the length, I'll show you all. Let's also randomize the seed value. We add to this with that. What? Okay. Context. The new search is very weird when it comes to context. So here we can make these as spirals. I think that's a bit better. It looks more root-like. But I also want to be able to invert this. So I will use a switch node. And then I could do this in two ways, yeah. Here, let me just go and multiply this, but I also want a Boolean random value on the spline domain that switches between 1 and -1, so that we will multiply the rotation by 1 or -1, or I could just have it be so that they all have variable rotations. So here we have something more like a root. I could keep multiplying it. So that, yeah, we don't even need the sine wave. That was all done for nothing. That was all done for nothing. But hey, learning experience, good enough. Simplifies the node tree. Good enough for me. Okay, let's set this to... I could set this to be a float. I could just do this and then set this to 1 and -1. Maybe that'll give better results because there's more variation. They're not all spinning at the same rate. But that does mean that some of them will be basically 0. I could make it... We have this value going from 0 to 0.1, so if I have the same random value with the same seed value, I could, in theory, make it so that the distance from the center would make them rotate even more, but that doesn't really matter, because the rotation means less the closer that you get anyway. Could you make a geonode transformer? If you're talking about a transformation node, yes. It's not exactly hacky since we do not have proper matrix math. Well, we have the regular transform geometry node. We could make that for fields, but I kind of assume that you are talking about a transformer as in the converting robots. In theory, yes, but it's a little more practical to do that completely manually, because art directing all that is, you know, just a bit more difficult. So here we have this. I think I need to reduce the amount of branches. And another downside is that I should probably... For the rotation, I should probably make this the duplicate index so that... And that does mean that we can eliminate this node because that'll be on the spline domain anyway. To make sure that it doesn't do that jumping part, because we are splitting... How do I make it so that when the branches split, as we can currently see them, that they do not do that little duplication jump? How? Like one way... Okay, I'm going to store the duplicate index. So let's just do that. Spline domain, integer. Let's just put this here, have it be DID for duplicate ID. So DID. Plug this into this one, eliminate the evaluate on domain. So as we can see here, which as you can tell by my very pained voice, I'm very happy that all these now look exactly the same. Anywho, should be fine. The simpler node setups are probably the best. So I'll put that there. And then I will put you like this, just so that we have the frames here. This will be spiral. Fix the spelling. Spiral. Spiral offset. Yeah, that's fine. That naming is fine. Random rotation. Okay, so all of this is just to make it so that it'll rotate around the spline center, and the duplicates will be scaled correctly. So here, the branches are too big, so let me reduce them. Now, at this point, I can turn up this amount so that we have something that looks rather good. It still is irking me that they all have the same kind of, Oh, wait, but they're not, they are not jumping anymore. Huh, how about that? Even though that would make it so that they are jumping. So I just need to plug that into there. Now they will not... Okay, they are now splitting. And they cannot jump. They are literally copies of themselves with all their settings. Very nice. Very nice. So there we go. Now we have that. Again, the downside is that these are becoming way too big. They shouldn't be. Here we only have 3 duplicates. So I'm a little, I'll have that be 4. So now what I need to do is, I really wish that I could use the hair curve so that I can get the fast hair rendering. But since that does not seem to be feasible at this current time in space, looks like I will need to do it the extremely slow way. So, well, what the heck? Let's do it. Curve to mesh. Have it be a curved circle, but to prevent my computer from having a very bad time. Circle. Circle. I need to actually spell circle correctly. Let's do that. The radius. Oh, that hurt. That was a lot of lag. That was a lot. So here we go. We have quite a bit. 3 frames per second. 3 frames per second. Alright. Alright. Let's go and set the material. Hey, if we have to do it, we have to do it. And yeah, that's fine. Let me just set it to be the default material. Let me put this into a frame. This is where it gets to be not fun at all. Shader ed. Well, the speed wise. The material we can have some fun with. I am just not at all looking forward to actually dealing with the rendering side of it. With the slow rendering side of it. Okay, material time. Let's get our attributes that we set. So here, let's just get the gradients. So, in my infinite wisdom, we only have that gradient currently flowing, when I should have multiple gradients for... Actually, no, I can do that in the rendering part. Splitting is working as intended. So I should have this be the emission, multiply by a bit, and make it green. So let's go do that. So here, let's make it green. Let's also, before I forget, let's not use this ugly green color. Let's switch this to be the AGX color management. This will give us better greens, better saturated light values. And also, if you want better emissive values, use the power node and set it to like maybe 10. This will give slightly better fall-offs for all that. So here we have something like that. It's pretty good. I think the value might be a bit too much, even still. So there we go. 3 frames per second for even the simplest simulation would be amazing for what I'm working with. Ah, you must be dealing with something very, very complex. Like, I don't want to do this, but maybe I can make this so simple. 3, yeah, 3 is fine. Maybe I can handle everything else with like the bump map. And the other downside is that I think the branches are splitting a little bit too fast. Even the lag slows it down, obviously. But let's not worry about that right now. I also need to do a few other things. So let's go and store the gradients for me to make a curve UV map, because there was a plan to make a curve to mesh with a UV output, but unfortunately, the Blender devs never completed that. And the current workarounds lead to errors, which will be extremely bad with the curved circle because we only have 3 resolutions. So the gradient around that part will loop around because it's on the point domain and all of that, and there is no corner domain on an edge. So if I were to fix that, it would be difficult, maybe even impossible. I don't know. I could always use a trim curve node to split the ends and then merge them in post, which is a horrible, horrible workaround. A workaround to get curve UVs, we should not have to split the mesh and then reform it. And that also means that we can't fill the caps if it's not cyclic like that. So we should have a curve UV output, but that is in it's in purgatory at the moment. Let's get gradient X and gradient Y. Here, let me actually name them. Gradient Y and gradient X. Gradient X. Let me copy the names so that I can put them in the shader editor very, very quickly. So we have the power, the energy, the split gradient, which I probably should have named it that. Okay. So now if we have this, we have the gradient from there to there. Maybe I should have this be the length, but we also have the gradient that goes around. Now, unfortunately, again, because of the workarounds that we have to do, because there is no curve UV output, this will basically be mirrored on both sides because this vertex has a dark gradient, that one has a medium bright one, and that one also has a medium bright one, which actually this is even worse. No, this one has a slightly darker one that has a slightly brighter one. So this part will have a squished mirrored UV map, while the other one should be fine. That happens for all curves that we use this method for if they are a closed off circle or shape that is closed off at the ends, if they are cyclic. So let me use a combine XYZ node. There we go. And unfortunately, no, the curve info node won't work because we don't have the good curve rendering. I wish we had a node that would convert regular curves into the special curves so that we can get that good, fast curve rendering. Because currently having a workaround where we need to go and create a special object, like these two are special objects. They have data that no other curve, I think, can have, which technically these ones have special data, but they all have the control panel stuff where you can edit all that. These ones are weird. You have to select an object to add these, which is weird. It parents the newly added object to that one, adds in a geometry node group. Maybe even several if it's per node. I do not understand the methodology behind it. It is very different and much more confusing than the old hair method here. You have all the settings very well there, while with the other one, they're all very, very scattered. Okay, so now let's have a noise texture, 2 dimensions. I can always put in the curve ID to get some more variance. Variance, not variance. There we go, so we have that, and then we have this gradient. You may be able to see that stretching. Yeah, you can see that there. It's disgusting. Uh-oh. I'm just going to assume... Okay, yep, that is clipping. So, looks like I need to plug in the length instead of the factor, so that we don't get that slip slidey stuff, because all the other parts of, all the other parts of this are being controlled by the curve length, its physical length, rather than just a gradient from start to end. So there's that. So if I say use a color ramp, we can have that be a kind of mask for our emissive values. So if I do this, and then multiply our power gradient by that before the, power and fall off and all that, this should be good. Where do you think? Oh, and also this should be dark and diffuse, and I can put in a bump node. Here we go. So here we can see that value properly working. You can turn up the roughness. Do it like this. There we go. Now, these are looking more special. Since the splits are happening, they are duplicates. Like, in theory, I could have a main branch with lots and lots of duplicate. I could do that. Oh, dang. I can make it so that every single time a split happens, the amount of splines on that curve decreases. So, I need to do that. Okay, here we go back again. So, yes, I can, wow. I am being smart. If we get the split count, we can divide the total amount. Let's get an integer for the amount of initial, you know, fiber splines that we want. And then we divide that by that to the power of 2, so that every time a split happens, the amount of splines per thing decreases. So it'll start off here with apparently... Oh, no, I wanted an integer, not the index. Okay, let's make it so that it starts out with 20. 20 splines right here. And then when a split happens, a jump happens, which I'm not the happiest about. Yeah, how do I make it so that when the split happens, the indices will like be kind of split between the two? Yeah, it's working. Actually, wait a minute. So it's divided by 1, divided by 2. Yeah, no, that's not accurate. It needs to be to the power of 2. So to make the... Oh, this is a thinker right here. So essentially, what I will need to do is have the duplicate IDs. But then, when they... Oh, wait. Oh, this is going to be quite interesting. I need to make it so that... Oh, dang. I need to get an is... Oh, wait, this might have to be... Huh. Do I need the repeat zone for this? Okay, this is getting to be a little, So right now, I'm going to try to fake that when the splits happen, some branches just diverge. So it would be seamless to the degree that the two parts, instead of moving in parallel, like half the splines start moving in a different direction. It's technically an illusion because they're being copied, but I need it so that each copy will only show half of the picture. With this one right here, it is... Wait a minute. Or I could make it so that all the splines, there are truly 20 duplicate splines every single time. And then the ones that are deleted... go up by the split count. But the curve ID decides... I need to think about this one real quick. This is going to be a brain scratcher. I have the split count. If I can pull this off, this will be impressive to me. If I get this, then this means that... if I multiply by 2 and add these together, then that means so, split count. And then I can have an ID for every different one. Which means that I can delete the correct amount of splines, but then flip which IDs are on which. So that effectively, I would eliminate the spline. A brain scratcher, this one is. So essentially, when the first split happens, I need to mark splines to keep on this side, but then have this one be the exact inverted one, which is why the is duplicate part would be good. Ooh, this is... Ooh. Okay, I'm up for this challenge. Rendering could happen next. I just want to get this little brain scratcher working as intended. So we don't necessarily need you, but I'll keep you here just in case. So every single time there's a split, that gets divided by 2, which is correct. Which means that I can do a greater than and say, if, oh, wait. Because I want to try to do this in a way where... I think I figured it out. I might have just figured it out. The old wrap node. Now the thing is, with this node, if we set it to 20, or maybe 21, we use a greater than. This should be at, well, I'll have to. No, I need the duplicate ID. The max, it'll go from 0 to 19 technically. And if it goes up, it does that. But then if it's a duplicate, with the is duplicate thing, it will invert. So I need to do a and node. How do I, wait, wait. Okay, no. Need a not node and then a switch node. So this will switch between this value and the inverted value, which basically I changed the greater than to a less than with the not node, but that's not too important. If I switch between that and then have the is duplicate there, I'm just switching between that value and an inverted value based on that. Did that actually just work? Okay, not entirely. Okay. So the problem is, yeah, the new splines are being created on the fly. But the splitting does appear to be doing its job. So here, it actually looks like when they split, parts actually look like they're splitting. Except... Okay, so it looks like it's actually working. The thing that I need to change is that... Yes. Every time a split happens, every time a duplication happens, half of them get eliminated to compensate for the doubling. But then... Yeah, no. Yep. I know I'm saying that a lot, but my brain is going at 1,000,000 miles a minute. I think I might have done it. I think I did it. Did I do it? I did it. There we go. I made... Okay. The lag is becoming a problem. It shouldn't be this much of a problem. But the illusion is correct. No jumping. No problems. The only thing is that we don't even need... Whoa, we don't even need that? Split count. Is that on the spline domain? Because this, in theory, should be lightning fast. Because it's on the spline domain, and there's only like, what, 24 splines at the moment? I am just going to... Okay, this will be render. And then this will be the Bezier curve. This is the sim. Sim and render. Let me just go and move these into another collection. Geo. Let me also save this because I have not done that in a while. We are past an hour and 34 minutes. Okay, that's not the best. Spline, spline, spline. Yep, that should be good. I don't know why it's lagging nearly as much as it should. Let me use the timings to figure that out. Okay, it's cached at the moment, so that should take nothing to go and look at. Where's the big lag spike? Looks like that's evaluating it. Huh. Now... why is it lagging so much? Meshing is still having that much of an issue? Is it the resolutions that we're working with? Wait, let me... okay. It's time to spreadsheet this. Okay. So, yeah, this is... oh, this is... something else. Technically, we don't need this named attribute, but I'm going to keep it here just to keep everything nice and, tidy. So this... I need to label this so that future Ben knows, what's going on. Split... but... huh. Keep consistent ID after split. Keep consistent duplicate ID after split. So, what I'm currently thinking is that since we have 20, value should be well, wait, there might be a way easier way to do this, but I'm not sure. There is a much easier way of doing this. I'm pretty much sure. I just, oh, nope, yep, there is a way easier way of doing this. But it would mean the, yeah, okay. But, no. But, yes, but no. Okay, I'm not sure. But it seems like, at the moment, this isn't too bad in terms of time. Like, this whole operation is not... it should be faster than that, though. Like here, how many splines are on screen? I'm hoping that there's like a rogue thing somewhere in here. Shoot. Need to actually view on before then, so that we can actually see what, oh my god. They're not actually getting deleted. Why are they not getting deleted? Or did I break it? Yeah, they're not getting deleted. I think I must have broken something? Must have. But what did I break? Duplicate ID, that's working as intended. When that happens, it wraps it to be half of itself. And then it chooses half of its one. Oh, viewer time. Okay, let's take a look. And I can't accurately see the viewer because the offsets are not occurring. But okay. I broke it. I will fix it. So here we have that, and the split happens. Nothing's happening. So we have that value. Then when split happens, that happens. Yes. When that happens, that happens. Then that happens, that happens. Yeah. It should be functioning as intended. Oh, wait a minute. Okay. Yep. I know what's going on. Yep, okay. So not only do I need to delete those parts, but I also need to delete the ones that are greater than, yeah, that current value. So, yeah. Yep. So if the duplicate ID greater than the half, then elimination will occur. Less than? Time to test once more. Okay, yep. Duplicate happened. Then that happens. But, okay, it looks like we have a add by one issue. That can be fixed. That can be fixed. Okay. So with this happening, we should be in business. So on the upside, okay, yep. We can see, yep, seems to be working. Now the downside is that it happened first, so I need to do that. That, and that. Yep, and here we can see, yes, okay. Let's take a look at this again. Now there, it looks like it actually split. Any jumping? Nope, jumping is still, dang it. Dang it, dang it, dang it. Ah. Hmm. Split count is there. This may be one of those, hey, just figure it off stream kind of things. Okay, another thing for the viewer here, so that I can actually see what's going on. These should be inverted, so I'm just going to make a quick little detour so that I can easily view what the heck is going on before the splines actually get deleted. So that and that. Half of these should be visible every single time. So here, after the split happens, okay, so half of these should be one color, and these should have the exact inverted color. That's why the switch is here, which that one should not be tampered with. Now, the problem that I did not take into account was, here, let's just put that from over there for now. What I did not take into account, which I thought I did, was that when its split happens, the amount of vertices get split, the amount of splines gets halved to compensate. So they get multiplied by 2 and then divided by 2. And then inside of that divided amount, half of those get selected. And then on the duplicate, they have one value, on the other one, they have the other value. So every time that happens, it happens again and again and again and again. So the duplicate IDs all have one singular value. Some of them get halved, and then when they get halved, the other part should go over there, but that has to happen multiple times. So that's the part that I'm forgetting. And then, as we can see, wait, where is the viewer? The viewer ain't viewing. So here that happens. So yeah, that should not be occurring. what should be happening is, let's start with the basics. Every time there is a split, the 20 gets divided by that. So we have 10, which means that something's greater than that amount, they get eliminated. Wait, what? Okay. No, if that's greater than that, then there we go. Okay, yep, that's more like it. That's cause. They still, okay, they're still, yeah, they're still splitting. And not entirely accurately, though. Ugh, shoot. That's just an add by one issue. So we either need to add one or subtract. Yeah. So just subtract by one and good. Okay. Let's keep that block. And make it so that this is just remove half. But the thing is, inside of each of these halves, their IDs need to be 1. Oh, dang. This. Wait a minute. It's inaccurate. Even still. Come on, why? Something's not right. Yeah, that should be functioning. Then when a duplication happens and the split happens... Oh no, okay, no, that is working. Okay. Then when the split force happens, boom. Wait a minute. Something's still not right. Something is still incorrect. Or wait a minute. So yeah, that definitely should not be occurring. Like, what I could do is just say, like, I could run a simulation, and then whenever this value changes, I do this splitting algorithm. But I want to do it without a simulation, to give the illusion that it's working exactly as I intended. This is faking part of it. So this shouldn't be... This shouldn't be a part of the tutorial. This should be something that I figure out off stream, or on the live stream. These aren't tutorials, if you could not tell. But yeah, okay, let's set this back to 3. I'll figure that out another time. I'll just eliminate those for the time being, so that we can watch the show. The show is still just a wee bit underwhelming at the moment. I should probably have it so that there is just a little bit of light going through at any given time. Okay, no, this is our UV map, so I should go and put it in a frame. Yeah, let's just spend our last 10 minutes of this 2-hour live stream. Yay, an hour longer than usual, as usual. Okay. Yep, that's as intended. Put the blocks where the blocks go. Just as Tetris taught me. Let's put this here. It still is a little... Okay. That's a bit better. Still having some of the green pop through. That you can still see that kind of energy going. Oh, shoot. Should I have it so that the branches rip apart a lot faster? Like there's more force behind it? So that it's not quite as gentle, it just goes in kind of more snaps. And these branches should be a bit more green. And the bump node, I could also use that so that they look more like vines if I have like a spotlight on them. So let's just do a quick bump map. Bump node, it's not, well, tomato. And these all still have, when I figure out the IDs, I can make it so that they all have a different texture on them. Okay. So, another one of the downsides is, again, that the offsets are not... the pinning is still not great. And, okay, another thing that I found out is that I do need to put a dampener in here. So that the velocity, some velocity is actually lost, so that they can actually settle down. That's too much. I want quite a bit of floating as well, but just, you know, not too much. So that happens. That happens. That happens. That happens. Now, again, this will look better once I get the actual split algorithm in there. We won't see this fine array of stuff like that. Branching, still rather icky. So if I just have this... Oh wait, no, I don't want it like that. I want it like basically that, so that the only thing that doesn't move is the other thing. But I don't want it to move that much. So this should be at the midpoint, so that we can still have like some of that occurring. Or how about this? 0.75 and 0.25. So that it'll be a gradient, but the gradient is right in the middle. So that we can actually see that happening. Still not great. Shading needs work, all that good stuff. The bloom still has quite a bit left to be desired, and since I am using the new AGX color space, I can push it to its limits. Maybe I should use my fancy fall-off technique. Using a minimum, a logarithm, all that good stuff. So minimum, logarithm, and then we need to multiply by the first input because I still don't have a great way of doing this. So 0.999. This ensures that the gradients look quite crisp. I still need to find out the actual right algorithm for this, because it's currently the only algorithm that I've found that is close enough is shoot. Here. Something's still not right. Okay, that's a little... Okay. The fancy light fall off is doing its job. The downside is that the texture is being... I need to figure out that proper splitting kind of function. So here we have something... Wait, do I even need it at this point? Here, let's just go with U for the time. I am confusing myself. That is what I am learning. I've been doing this for too long. Again, what I've said before. But yeah, let's set it to ease. That'll give us a better result, I think. There we go. That's a bit better. Then maybe I can't, no, I can't offset the gradient because that is done in, yeah, no, that's better. Now we're getting that nice bloom off, and I can make it a bit more, and then I can use the noise to reel it in a fair bit, even though it looks like it should be like only slightly inhibited by this noise texture, just to give it a little bit of texture. That's mostly there, but maybe a bit of Fresnel. Still not quite the happiest with it. But I think it may be good enough for what I'm doing here. So for the color... Oh, wait, that looks good. And then I just need to pick a really good camera angle to go along with it. So let's change it back to kind of, yeah, that kind of green. Another thing from the show is that there were like a few other colors mixed in with everything, but I'm just gonna pick and choose my battles here. I want that to be like that, but the problem is, well, should be fine. Should be fine at this point. Okay, let's just go and do that. Okay. GeoNode editor. Okay, I just need to figure out that splitting issue. Like, in theory, like the efficient way, words. The efficient way would be to make it so that the index happens. And then, like, the splits get split, but only split that by the amount that they should be split. The problem is, they're all the same. What I need to, like, make a cumulative is duplicate value, so that if there's a duplicate of a duplicate, the duplicates get added. That might be needed. So let me go into the GeoNode editor and actually implement that. So I have the split count, but what if I have like split duplicate count, yeah. So that one only gets added if, so this will have to be an integer value, where only if the is duplicate value is true, one gets added. So, yeah. Dupe count. I'm just going to label it very, very generically. Integer. So only the is duplicate gets added. Oh, this is wonderful. This is getting so messy. Again, elegant solutions are difficult to do. I will try. So now, here, I'll just label it dcount so that we can see the name a bit better. So on the plane, let's add in that named attribute into the mix. So dcount, we should be able to see which one. Hello. Oh, there we go. So here, they should, we can't see them get brighter because of them going above values of 1. So here we should see values getting brighter every time it happens, but it's not doing it. Oh. Oh, that's, okay. There we, okay, yep, it is working. So here we can keep track of which splits get split again and again and again and again. And since we have that value, I think this will work. Yep. I think this will work. We just needed the right data. Yep. We just needed the right data. So now that we have that, which ones are split again and again and again? This means that I can only duplicate the splines that work, but then have a quote-unquote ID for the correct ones. Yeah. You know what? It would be extremely invalidating, but kind of relieving if I just have the duplicate amounts every single time if the IDs were consistent. So I'm just going to try that, and maybe all this stress, it was just a little bit stressful. If all that just was not needed whatsoever, I would be kind of overjoyed. So if I do this, just swap it out with the actual index. No, okay. So some things do still need to be fixed. And then that happens, and then there is nothing left to split. So these will run out. Even though I think we may need to add 1 to this value so that it's like kind of accurate. Or no, that should be fine. So let's hide the original, by the way, so that we can only focus on this part. We don't have to resimulate it every time, so we're only focused on that part. So wait, on the last frame it actually worked as intended. There was no jumping. So here it's like, wait, what? And then the last one split. That's how it's supposed to go. So I just, again, the split ID I need to make like consistent, which is going to be difficult for me to figure out. So this is spline count, duplicate count per spline. Count per spline. We're over 2 hours. Okay, let's just keep going. It would have been more efficient to pause this, but it's good if this becomes concluded. So let's keep going. Let's keep going. So we don't need you. Yeah, let's just even though you But no, we are setting the ID. So why would we set the ID if we already have it? Yeah, no, I am making a new index from scratch. So the thing about that is that we just need okay. We need this duplicate index. And then every time it splits, we need to, okay, imagine the duplicate index as this. As it splits, like this is 10 and 10. These both have a value of 10. What we need to do is give this branch, the split branch, to go from 10 to 20. Well, okay, let me rephrase this. We have 2 branches right here. That used to be 1 branch. This branch had IDs that went from 1 to 20. Now we have 2 branches that are 10. We need to make it so that this one goes from 1 to 10, and this one goes from, I guess, 21 to, or goes from 11 to 20. That didn't make sense. I apologize, but here we go again. Okay, here we go. Delete this. We're starting again. The only thing that needs to actually work as intended is the other value. My throat is getting sore. So I should probably stop doing this soon. But if we get the duplicate count. This only adds in a new ID when a split actually happens. We need to do that, but the reverse. So I need the duplicate index. But every time... Every time that there is a split... Nope. Nope. For a moment there, the branches synced up with the beat. So how do I make these IDs right? All we have is the split count at the moment in the duplicate index. How do I make it so that the is duplicate part we need a switch node. No. Think, Ben, think! How do we do this right? How do we do this correctly? Like, it would have been easier for me if I just set up the simulation so that all the splines were calculated at once. And then I just made it so that whenever a split... Yeah, that would have been the right way to do it. All of them have the same velocity. But then when a split happens, their velocities diverge. But instead I'm doing this kind of in a backwards way. Where I'm duplicating them and then I'm unduplicating them. But I made this bed. Now I must lie in it. So, yeah. Nice. Nice. Okay. I have a plan. No, I don't. Do I need to bring out the whiteboard for this? Like the... Okay, so only spawning in the splines we need is functioning. Here, if we put this here, the amount of splines stays consistent as we intended. Goes from 20 to 10 to 5. No, it's not accurate unless it's an even number. Or no, if it's a prime number. If it's a prime where the value is low enough. Or no, that... Oh my god. Okay. If it's a power of 2, it will only work if it's a power of 2 number. Okay, 2 times 10 is 20, no. No, okay, no, it is working. Okay, I'm getting confused at this point. I apologize for that. But I will figure this out. I have to. So, we have this value. We only add this value to that if it's duplicates. Wait. It has to work. I have the data. I have all the data I could need. I have all the data that I could need. What more does it want? What more does it want from me? Just have all of them so that we can view everything once more. We have... There it is, okay. So we have that. But when the split happens, Oh, that's a split count. No, I wanted the split ID. Duplicate count? No, oh, yeah, duplicate count. That goes above a value of 1, so I need to divide it as I said before. I need to transition this into a float viewer. So here we have the levels. And all of these need to store a certain ID. So this one has like an ID of 0 to 1. This has 2 to 4, and then that goes so on and so forth as this goes along. Yeah. Yeah. Yeah, wait. Yeah, no, that should work. My brain is expanding. Yeah. I just need to multiply the duplicate count by this value. So, okay. I need to multiply the duplicate count by this value so that now it goes through the right amount of iterations. So it'll do that. And then I need to add that to the duplicate ID. And that should give me what I want. Am I logicking? Am I logicking this correctly? I don't think so. There. Oh. What? Subtract. No. Still not doing it. Let me think about this again. So on split 1, this value is now 10. Which means that there are 10 bundles in each spline. Due to the duplicate count. No, the names are all wrong with this. Okay, let me rename so that my brain doesn't get mixed around. So this part right here. Oh, it's getting too big. Okay. Is duplicate. Is duplicate count. Is duplicate count. Okay, no, count is duplicate. I'm just going to be doing... Okay. Count is duplicate. Count is duplicate. Yes, that's what it's doing. It's counting the is duplicate value. How many times it is the duplicate. How many times 1/2 is the off half. Okay, now that I have a proper naming convention, essentially, we multiply this value by 10 so that that happens there and then that goes into there. That should be the case. Or just... Oh, maybe that's why. Nope, still broken. Count is duplicate. So it's... We multiply the isCount duplicate by 10, so that offsets the duplicate index, which goes from 0 to technically 9, then it adds that to there, which again should mean that if we divide this and take a look, That snapping should not occur. It only works on the last one because there are literally no other combinations that can happen. Oh wait, I think I know what's up. And then here, okay. Yeah, okay, I only need, yep. I think I might know what's happening. I forgot to actually do the switch between... Actually, wait. No, I have the duplicate counts. So the first one, it should work as intended, because when the actual split occurs, it should go from... I'm going in circles. We still have 34 people here. I'm surprised we still have that many. Thank you for watching my descent into madness. But we have the count is duplicate. So that one's 1. That one is 0. That one is 1. When the next one I think I figured out the problem. I figured out the problem. So, the problem. Here's the problem. Now that I figured it out, I'm not sure if I can even fix it. I can barely even see it. Here, let me set this to the PowerPoint 5 so that once it gets like super duper bright, I can handle the everything. I was like, it's still in. Why does it still? Okay. So here's our issue. I was assuming, oh, wait a minute. Every time the duplicate happens, we're still in the clear. But we're not. Because every time one of those happens, that one gets bright again, so the offset cycles. Wait, but I thought I fixed that with that part, so it should compensate. Should compensate. So every time a split happens, that goes to 1, 2. Like, the amount the count is duplicate adds. Man, we ran out of music. I've been going for so long. Let's get that running again. I will figure this out by 2:30, and then I'm gonna 2 hours and 30 minutes, and then I'm gonna cut it off there. So simultaneously, as this value becomes 2, or no, that might be the issue. I might have to... multiply this by 2 and then add in the is duplicate amount? But no, I'm going in loops! Yeah, no. The is duplicate value. The is duplicate value and the count is duplicate are close to the same. Because this is just a counter. So if I were to say use a wrap set to 2, it would just lead to the is duplicate counter because it's like yes, no, yes, no, yes, or would it? This is hurting my brain. I need to make it so that this value eventually becomes a gradient from 0 to 20. Which it is. It has to be. Here, let me use the domain site domain size to properly account for all this. So I just need to take the spline count, divide that by that. We should see. Yeah. So, yeah, we are seeing a gradient unfold. Which, thank goodness. Here, let's multiply it by 2 so that we can... Well, actually, no. We only want it multiplied by 1 so that we can see all the values here. Thank goodness that I set out the... Now, why is it getting darker than it should? I need to do spline count plus 1. I will figure that out. So here, it's making an accurate gradient the more splits happen. Yeah. It's doing its job. So, yeah. What should work is now I just... But that's what I did before. Just adding that to that, and it should... Shit. You're watching a man's descent to madness. Into math. Too much math. For my own good. That's why I have that viewer there, so that I can actually keep track of. Yep. Okay, is there any part that could be incorrect on here? Nope, everything's reliant on the DID value. Which means that that one is not. You know what would be really helpful right about now? Is my viewer node that I made with the repeat zone acting as for each loop. Which means that would be really useful to have a for each loop right about now so that I can actually see the ID values properly. But the for each loop is on the... I'm not sure if it's coming in 4.1. It's only been mentioned like once in the past. It was mentioned once, only in reference to another project, which was about the capture attribute node's limitations. So once a capture attribute node gets fixed up when it comes to like joining geometry, I think maybe only then is when we'll get the for each loop, which it's so frustrating not having the absolute basics when it comes to like coding stuff. Like all of these use for each loops, just for each point, for each edge, for each face, for each spline, for each instance, but we don't have a method to be like for each face island and so on. If we had that node, so many things would be possible, but we do not have it. So there's a demo out there and I would want to get my hands on that demo, but it's probably buggy, which is why we don't have it at the moment, which is why I can't use it. So yeah. So, okay. Just to really be a dead horse. Okay, I think I found the issue. No, I don't think I did. Did I? There's one. Yeah, no, I don't think I did. I don't think I did. Yeah, no, that just gets brighter as intended. So this part we do not need to worry about. That just takes the amount of splines. Here, let me cull a lot of the stuff that is very much not needed. We don't need that, we don't need that, we don't need that. This, again, goes from 20 to 10 to 5. And then it gets inaccurate because you can't divide 5 by an even number. No, wait. Oh, this needs to be a power of 2 number. Yeah, 20 is not a power of 2. Okay, 2 No, 2 to... No, I need 6 to the power of 2. What? 6 to the power of 2. That should be 36. Right? If I have 36, then that can be divided, and then that can be divided. Then that could be divided. And then that could be divided. 6 times. We can get 6 divisions before it breaks. And then it breaks. Big time. But there shouldn't be the jumping. I did my math. I did my homework. Did I just need to subtract it this entire time? Is that the issue? Nope, there's still jumping. Nope, still jumping. So 10, and then on the other half it adds 10. And that goes into there. So the first round, there shouldn't be a problem. Then the second round, there's no problem. No, the second round there is a problem. And I can't see the first round. Tell me why. 36 is square. Yep, sorry, that's what I meant. I had my first project that required a for each loop recently. It was awesome. Nice, very nice. So, once again, we have a value that goes 0 for 0. Oh, this gets divided by 0. Or, wait. So on frame 1, it's bad. So if there are no splits, then it's bad. But then once... Okay, I just need to keep that in mind. So it's disappeared here literally because it's not supposed to... Okay, no, that's only a problem when the split count is 0. But when that happens, 36, a very nice even number that my brain will not have trouble figuring out. Or no, is it 32? Yeah, yeah. My brain is... Wow, my brain is having difficulty today. Yeah, no, I needed 30. Wait, but that, wait. I need... I had just the biggest brain glitch I've ever had. My brain just like short-circuited and then it needed a good like 3 seconds to completely reboot. Apologies for that. I am very surprised by that. Okay, duplicate index. Duplicate index always goes through the indices properly. If we visualize that, it'll always be the same. So once again, get that viewer node. I need that. Then I need to do this and divide it so that we can actually see what's going on, because I can't see values that are greater than the value that are valued in value. So here it's always that. That will... Wait a minute. Let me put the accurate one in here so that I can see the values properly traced. That happens, yes. Then that happens, and then that happens, and then that happens. The only thing I need is for those to be added correctly. Was the subtraction the right way to go? Something, yeah, there's just one piece of the puzzle. Oh, here they're still just frozen. What's going on? Why? How, what, where, why? Now let's multiply this by a bit. Okay, so frame. This is getting very annoying very, very fast. This is just taking the normal IDs so that there's no... Oh, there is... Wait, my brain is short-circuiting again. It's funny how this has taken over an hour and a half. So, I need to call it. I really need to call it. Because, yeah, this won't even be visible in the render. If I started out with the splitting branches in mind, that would have been so much better. But here I am, an hour later. Why do I keep ruining live streams by going off on a tangent and I just stick with it when I should have said, you know what? We're not going to worry about that. It doesn't need to be super duper accurate. We're just doing what we need to do. Just do what needs to be done. But I must figure it out. That's the only way I'll be happy is by, well, not, you know what I mean. The only way I'll be satisfied with this project is if I figure out... Huh, interesting. Some of them are not jumping. No, those two both jumped. I'm just going to hide this so that that's not even a factor. So, yeah, we only add to that duplicate index. We add 10 to it. Or, no, not. Okay, here we go again. Two, 4, 6, 8. I can handle 4. Why did that jump? What? Okay, what's this output value? Attribute statistic, you are my friend. At this current time. Tell me. What does the mean? What is it? Sorry, we need to actually calculate it to see this part. 1.77. 16. And it goes to... Next cycle. 4? The power of 2 was wrong this whole time? Wait, no, it couldn't be. Okay. Next cycle is 8. Now this one. Yeah, no, that's wrong. Why? So it has to be the power of 2, but why did it... Okay, no, it's right. It's right. I'm getting all mixed up. So this needs to be... I'm sorry. Why is it jumping? It's 4. No, it's wait. What? 16. Split count is 1. I need to add 1? I need to add 1 this whole time? Is that it? No, but no, it wouldn't even matter. Yeah. This just means that, you know, split 1, we actually see that split happen. When we don't need to. But what is going on? If that caused it to work, I would have been really happy, but also like, why the bleep? Okay. Wow, this live stream is a good... It's a documentary when I literally said, if I go over an hour, then things don't turn out well. And we're literally seeing that play out exactly as I said. I said something. All that. Swap the power node with 2 at the... Thank you, Hayden. Thank you. A lot. It's still jumping. But not completely. Thank you. I cannot thank you enough. Now... Okay, it's still not flawless, which I need to find. It's just an add by 1 problem, I assume. Brought down by a simple thing, which makes me wonder if that was wrong. Wait, wrong thing. Is this wrong anywhere else? Where do I have that power of 2? No, that one's fine. Okay, okay. I forgot that I need to, like, undo it. Oh, dang. But there's still a tiny, insignificant issue. Where it's like that. There's still something that's just the tiniest bit wrong. Okay, no, that's causing more jumps. Subtract. What is, what's its problem? Count. Count. It's so close to being right. Because, okay, so here's the kicker at the moment. This goes, the amount. If you have 0 as the amount, it means 0. But the thing is, the duplicate index starts at 0. So if you have 1, these all start at 0. That's just the way indices work. Programmers were like, yep, that's the way. So that means that something is just the tiniest bit off. I will find it. Nope. Nope. It's like, oh, duplicate index. Wait, is that even the issue? Like, most of them are fine. Just one insignificant issue. It's once again causing a world of pain. And I can't just add it to either one willy-nilly. Because... So that makes it worse. That makes it slightly better. But every single time it goes through, that happens. Okay, we're at 2 hours and 40 minutes. I've spent way too long on a hack. Like, doing it the correct way would have been significantly easier. Significantly. Wait, do I need... Oh, I might need 2 different values for this. One might have to be like that, and the other might have to be like that. Okay, let's flip this around. Nope. Same issue. So what's its problem? Do I need to set this to the power of 2? Okay. Nope. Flip it around. Nope. Here, it should be like that. Here, let's set this to 32. So that we can see even more. Except there's just the slightest jump. Which, since both halves are there, that means it's reaching an index that it should not be able to reach to. Oh wait, do I just need to add 1 if it's the duplicate? No, it just is duplicate. Wait a minute. Do I just need to add 1 if it's on the other side? I kind of doubt it, but... Add flipperoo, flipperoo. Cool hotkey to swap the inputs of a node is Alt-S. I think they... Oh no, it still exists. I thought they discontinued it in 4.0. They're doing redos to everything. Very, well, let's just say controversial redos. Like, this is so close to working. It is causing the index hop. But it should be fine if I'm correct. Like, see? Like that. It's working as you would expect. Even when it's... Well, actually, no. Oh, wait. If we look at the chord, we can see if it's working. We might be able to tell what's going wrong. It looks like 1 is being removed every single time. Every cycle. Looks like 1's being removed, and that amount gets to be more and more. So, yeah, it does seem like we just need to, again, add 1 or add a certain amount every time. Something is just the slightest bit off. Also, wait a minute. Are they just being combined? Oh yeah. Oh, we should have been looking at this. See what's happening. Some are becoming more condensed. Yeah, some of them are folding in onto the same space. So, yeah, my kind of theory that they're all going to the same area is correct. They're not getting deleted, they're just going to where another index is. Which is why I thought that switch, like where I would just add one if it's duplicate, would work. Right, is duplicate, just add one to it and it should be good. We're well on our way to 3 hours. So here, and it's still bugged. Dang. It's frustrating. But that's causing more jumping than before. Nope. Subtract. Nope. Flip it around once more. Nope. How many were lost there? So here that happens, then... Is that split 1 or split 2? No, that's split 1. Split 1 occurs. At 60 frames, split 2 happens. So I'm assuming that split 2 should have 2 removed. Because there's just that slight inconsistency. 10 in there, they add 10, which means that it should be working regardless, but this thing has surprised me multiple times, so let's try it again. Like, if I had the repeat zone, this would be easy, but I don't want to have to repeat this again and again and again. In the time that I was trying to figure out this bug, I could have just made it so that this main curve splits with physics instead of the current rationale. Let's put this back as it was. Or is that wrong as well? Is everything in this wrong? Could be. How hard can this be? Like, I have... Do I have an index for each spline in the old one? Like, one that is consistent, not one that kind of reorders every single time. Like, it's... Split count seems to be the right way. Oh, wait. be a bug on my part, maybe not. Well, no, all of this is a bug on my part because I built it. So we only add to this if the is duplicate is set to true. That's only set to true if that's like that. So no, that should be right. I need to watch the data again. Actually, wait a minute. I can just watch this data by literally plugging in the count thing into there and then just watching the show. So there it's 1. What? Oh, right. And just add 1 because, you know, indices and all that. So here we have 1. It splits into 0. It splits into 1 and 2. Now this should split into 1, 2, 2, and oh, I think that's where it's going wrong. So it's 1, 2, 2, and then 3. Actually, I can make this even easier by turning off this part. Or wait, does that make it easier? If I turn off... Okay, if I do this, then turn off this. And then make it so that is literally the DID. Duplicate index, divide. Put that into there. So if I do that, and then also turn off U. I should be able to specifically see. Oh no, wait, I need a... Okay, accurate math, Ben, accurate math. Okay, let's just, got like 50, that'll be good. So here we see 1, 2, and this is, rewind a little bit more. 1, 2, 2, 3. I think that's the part that my brain is having a bit of a difficult time with. Because I thought, oh, all these are ordered in order. I thought this would be 0, well, 1, 2, 3, and 4. But it's not. And then when this happens and then that split occurs, we should see 1, 2, 2, 3. 2, 3, 3, 4. Okay, that's our issue right there. It's getting the split count correct. Oh, actually, that looks pretty cool in and of itself. Huh. GPU cables, everyone? Or computer cables, I guess. That's cool. That is another render. Oh yeah, oh yeah. When I figure this out correctly, that is something I will try. And actually, no, this is a better debugging method. I can actually see which ones are which better. Where the glitches happen in what order. So, okay. The issue is with the account is index. Or, yeah, the count is index. Because I thought every time a loop happens, it will do the thing. But it doesn't do the thing. Because these are incorrect. Again, as I said before, 1, 2, 2, 3. 2, 3, 3, 4. It's showing how many splits have happened. In this case, actually, wait, how many splits have happened? 3, yeah, 3 splits at 1, so this equals 4. So, yeah, it's not in order. So that means when this index gets offset, it's offset the same as this one and the same as this one. That's not what we want. We want this to be in order. So how do we make it so that every time there's a split, one keeps getting split again and again? I mean, I could just take the... I need to think about this one. I could keep multiplying the value by 2, but also adding the other thing. Not sure. Thought this would work easily, but I was sorely mistaken. Do I just need to set the is duplicate value to the power of 2? Because that's what I need to do. I know that there is going to be another is duplicate value, so I just need to make room for it. That's the plan. That is the plan. Okay. So the thing is, I know that there are going to be double every single time this goes through. So I just need to make room for it. Okay, let's take a look. Do I need to rebake it? One. It's hard for me to tell if it's actually working because I need... Did that do it? I don't think so. We have 3 on the first one, which shouldn't be the case. We have 4, 4. Yep, no, that is that's not the right way. This ain't the way. Or oh, I might just need to multiply it by 2 every single time. Simple as that. Let's hope. Reset cache. There we go. 1, 2, 3, 4, 5, 6, 7, 8. Alright, we now have a ID for every single one. And we can see that that gets to be quite a bit. Okay. That's what I forgot. I forgot a bit of the data part. So, this is no longer a count is duplicate thing. It's split ID. It's the ID. I don't feel good naming it that, but it's the only name that makes sense, that actually feels like it means something. Let's see. Okay, I think we are... let me save this, by the way, because I probably haven't saved in over an hour, which is very, very sad to say. Okay. Let's check it. Oof. Okay, I need to set this to the power of 2. Or no, wait. We already have proper data. Oh, wait, no, yep, split ID. There we go. It works. Pretty much perfectly, I might add. Even though the one downside is that when this one splits, it's doing the... yeah. I did it. With some help from the chat. So thank you very much, Hayden, for for aiding me along my treacherous journey. But now, here we go. Ooh, dang, that's a little concerning. So, again, I will reiterate that, what should have been done, I should have made a physics system where all these are lined up, but then when the split happens, the physical curves that are actually in the scene, because just as a reminder for those of you who joined in late, these are the actual curves here. They're one and then they split. They don't all exist at the same time. What should have happened, which I could have done. I could have done this. Actually, could I have? I would. Okay. If I made it myself, I would have to make my own, like, curve. A special curve node that would basically say, hey, here's your curve tangent, here's your curve normal, here's your curve position. Yeah, those are the three things I would have to store. And then also the curve ID. So that I could do that. Maybe for tomorrow's stream. But for this one, it works. The other method is doable, but it's a lot more math heavy. I saved the hardest piece of math for last. So... oh, and let's actually show... It works. It works. Let's show it in all of its glory. Here we have that. They split. No jumping. So the 3 hour, at the 3 hour mark, okay. Who knew that just one little visual thing would delay this by 2 hours? But we got it. Okay. Who knew that this could be brought down by a simple multiply by 2 problem? I just need to multiply the value by 2 and then add in that duplicate index so that we can get an ID for every single split that occurred. It was such a simple issue that delayed me by 2 hours. But it's been done. So there we go. Now I can unravel all of these. Now that I think about it again, this is still different from the Loki thing because one, with the Loki thing, the splits combine, which I could do. I might do that tomorrow because with the method I'm thinking up where we have a curve of essentially curve IDs where every segment along the curve I can have its own ID and then all those, yeah. Do the strands look a bit similar? Ah, we can fix that. We can give each one its own random ID for the shader. So yeah, and also I've incidentally made a splitting computer cable, which I'm sure many people will absolutely love. Man, this was difficult to figure out. Duplicate ID. Alright, now that this is done, it's time to just do the kind of, home run, I guess. Just name the things. Timings. The upside is that this is way faster than the alternative. It is so much faster. Significantly faster. Okay, what was I doing again? Timings. Timings off. So, save! Just in case I forget. So, yeah, let's set this to be 128. So that we can see it split again and again and again. So here we have the main timeline, shall we say. and then it splits, and then it splits again, then it splits again, then it splits again. Or actually, technically this isn't necessarily faster, it just won't become any more expensive in terms of the rendering side, because all the splines always exist, and so on. And then when it gets above the threshold, they just default to nothing, to 0. Which I could put in something that says, hey, keep splitting even if there's nothing left to split. Like when it gets to here, I could just make it so that they keep going. But that's I did what I set out to do on the rendering side on this. The only thing that is still left to accomplish is storing a random value per grid, per spline. So let's do it. We just need the duplicate index, put it into a random value node. Because this still isn't great because the actual IDs of the splines those still get jittered around because of the duplicate thing here. If I could set the IDs, the spline IDs to be this, it would be better. Because the actual IDs would be like that. But now I have like a supplemental ID that replaces the ID here. So, pick your poison kind of thing. Okay. Hello nerds, this already looks badass. Have I missed it all? You have missed it all. But you missed 2 hours of the... Okay, there was progress in the first hour. In the second and third hour, there was almost no progress because of a little bug that I just overlooked. And yeah, it was so annoying. But it has now been figured out, and now I'm just taking the victory lap for the last like 4 minutes. Let's look at the random thing right here. So now we have a random ID per spline that is consistent after the splitting. This took way too long. But since we now have that, we can... Victory lap time. I can use a white noise to add in a random value, but the problem is the white noise, because of float point precision errors, we get this little like weird glitching. So what I need to do is snap it by a very tiny amount, but then also add in an even smaller amount, or no, I add first and then snap. So that there won't be any like rounding errors. So here, well, what is going on? Okay, I'm just going to assume that's just errors with, yeah. Okay. So this is what we need to do in order to get a white noise value. I know, very little, you know? So if we want to re-randomize the random value, that's how we do that. So let's go and add to here, and then multiply this so that, you know, the noise textures will always be different for every single one. And in hindsight, I could also use the split ID to do that so that they will never cover the same ground, but this will be fine. So now these will all have a different texture, and it turns, well, I guess it's very difficult to see that with, there we go. So now we can paste textures on here and they will be perfectly fine. This took way too long, but it works. So now, for the end render, the idea is we just have one, let's restart this. We have one, it splits, and then we see it split again, and we keep seeing the splits happen until it turns into a massive tree. Which I think, you know, it went a little off the rails at one point, but like this camera angle, it'll look like a tree. Not the tree that ends up in the Loki show, but, you know, I think, there we go. All in all, I think it'll be good enough. Dang, this, and I'll do a viewport render, just cause, so that people can see all the hard work and effort that went into just everything here. And again, apparently this was the wrong algorithm. I should have made it so that all the duplicates were there, but then I would have to make another, maybe equally complex algorithm to bind, to parent all the splines together to make it right. Or would that need a repeat zone or a for each loop? I need to ponder. Nope, that would be fine. All I would need is the accumulate field node to accumulate, well, oh dang. This is confusing to think about. The emission looks off. Well, the only emission that is currently there is the gradient ping, I guess you can say. The surge of energy. There's no energy in the actual part just yet. So yes, that is correct. So I do need to add in some ambient glow. So we just have that. So we just have that. So I'll just add these two together. Or no, I'll just... Do I treat this as like a layer-based system? Where I have the main ping and then I just add... Yeah, okay. Let's do this. A layer-based system. Where we have the main... No, okay. Let's make this an actual layer-based system where I just add the layers together. So each one can have their own power, their own fall off, and stuff like that. So for this, let's take this node, bring it down. Ooh, that is ugly. Kind of like that. So making it even less. Okay, I might need the fancy light fall off again. Blender is not made to be layer based, so I am going to try to force it. So here, let's set that to be more like that. And I might just need another noise texture. So yeah, let's just have another noise texture with another scale. Again, layer based. Here we have layer 1. Let me just, oh dang. Let's put that in there. We have that for that, which I'm going to supplement that with that. And also, I should have this be the output for there, and here as well, the fancy light fall off. Yeah, let me label this. Fancy fall off. Fall off. Fancy fall off. Moving gradient. Moving gradient. Yada yada noise. Fancy fall off. Let's go and copy that name. It was such a simple problem, and it delayed me by 2 hours. Story of programming, I guess. Okay, so now that we have this, let's rescale. Okay, now where... Okay, now we have that. Let's go and change. There, okay, that's a little bit better. And I can have this noise be animated. So let's set that to be a bit less. Still just a tad too strong. And I could also add in some ambient animation to on the geometry side, on the geometry level. So let's just go and... Okay, let's set this there. Value, hashtag frame. Let's pray that this... Okay, nope, that does work. Use vector math multiply, so that I can move it in any direction I want and just add that into the fold. Maybe a divide would be better, because with that I can set the, you know, the speed to be a bit... Oh, dang. Oh, yep. That's that. I want that to be negative, or I'll just subtract from there. Okay. Here we go. There we go. Okay, now we're cooking with whatever heating system we use. Fuel, petroleum, natural gas, all that good stuff. There, yep. That's what was needed. There we go. Okay. So now wood. Okay. One thing that I wanted to make, that I also wanted to make, were particles that would show up every time the split happened. Because this is looking a little drab, just like this. So I might show... I'll do a viewport render, post that tomorrow. But then I need to set up the ambience. Then maybe... I should also store the move. I should store as much data as I can get. For the shader and, you know, maybe for other effects. So on the simulation side, I should store the moving, just the moving gradient here before it gets, I should store this gradient before things get weird. And should it be the fraction gradient? No, I don't think so. Because I can just fraction it in the shader. Okay, so let's store more data. This is a mess. Okay, let's try to unmess it by a bit, like, oh. Okay, don't hyperventilate. It's all part of my plan. My plan. Reorganize, make it better. So the splitting function is a lot bigger than I wanted. So, yeah, the other, other algorithm would have been better, but I started off with the simplest one, and now I'm paying for it. So let me put all of these in here. Split IDs. So all of that for the splitting. Dang, this is something. And also, if I wanted to, I could have the age of the splits be different per one, so that we have, that could be cool. It's fine. It's fine. I'm just going to store the actual moving gradients here. So that into there for the moving gradient. I'll leave the other one independent just because this was added after. So just leave it as is. So we have that, we have the main gradient there. Put them in the nice little boxes. Moving gradient. Now, yeah. Maybe I could make this, and we still, oh, the right elasticity. We still don't have that. Dang. It's fine. I did what I set out to do, and that's all I can ask of myself at the moment. Whew. I've done what I set out to do. And I am done. Alright. Just for some reason, I can't split up projects into multiple days. Like, Sometimes I can, but I don't know, doing it all in one just feels right. I'm still a little bit ticked at myself that, I'm still a little bit ticked that it was a simple bug. The tiniest little multiplication by 2 error, which I mentioned. I mentioned that earlier in the stream that I would have to multiply it by 2 to make room for the other index, but I just didn't do it. Actually, reorganized, it's not that bad except for this atrocity right here, which I could just make as a age value that gets wrapped. So, or no, this makes it faster. I'm okay with that. So there we have that. So let's go and get that moving gradients. Shader editor, yep. Layer-based system for this. So this is energy surge. And then this one's just the ambient side. Having them split just makes it a little bit easier to manipulate different effects at a time. Because if they're all intertwined and all dependent on each other, one thing just messes up another part in the lock later on. Causes literally a chain reaction. Well, if we have two separate chains and then join them together, if we glue them together at the end, it's fine. So yeah. Just that little bit. How laggy is this again? Okay. So this is going to be a third faster in the end result. So here, I'm going to multiply this by 100 so that it is even more powerful. Yep, good enough. I should also mention that since I now have the moving gradient, I can offset the moving gradient by the random value and then make like a fake version of that moving gradient to put into the other thing. Okay. Random. I did it. I actually did it. We're coming up on 3 hours and 30 minutes, which I think will be a good even number to, a good even number. Very nice looking number for this to end on. Oh, was that moving gradient, was that inverted this whole time? That's kind of what I was worried about. Is it? Is it? Oh, wait, no, this needs to be M gradients. There we go. And I need to clamp. Or no, I don't need to clamp it because I'm doing that. So, yes, okay, that works as intended. So now I just need to limit this again, like what I did in the GeoNode editor. I need to mimic the two because of, well, reasons. So now, when I do that, we can see, no, that doesn't look as good. That does not look as good. Nah, they should just be the synced version, but I could use the moving gradient data in potentially other ways. Because that's just that one, then it does that, so now I have like the full time with all of that. Okay. Yeah. Okay. So this is the end result. It needs a bit more fanfare, needs a bit more, like, edits in the visual side. Like, I could just make it so that the ID does determine how far away it is from this. Oh, dang. That's a bit more than I expected. If I make it 0.1. Okay, if I divide it by 100. If I divide it by 1000. Now that just looks like a regular cable. Oh, and that's interesting. Here we can see... Wait a minute. Oh, no, yep, that's correct. They don't split in half because the IDs don't work that way. Oh, that's interesting. Because the IDs are set up the way they are, it'll split the middle part and then the end part. Just because that's the way I set it up. It wasn't a good way to do it, but I did it that way nonetheless. Oh, that is funny. So in theory, I could make it so that with our little random rotation value, I wrap that... No, okay, I need to divide it by pi divided by 2. No, but since the thing spiral, it wouldn't make a difference. So having this be random is as good as we're gonna get. Except I could still make it so that it's a bit more varied to the point where... Okay, I can take that, put it into a random value, put that random value to the power of 2, and then map range it. So power of 2, or just multiply. No, but would I need to map range it? Just so that we get a better, kind of like a few stragglers, and then the main one. Yeah, there we go. So now we have it so that there's more frayed ones and less, yeah, more like that. So we have that, then it splits like that, then it splits like that, then it splits like that. Yeah, okay. There we go. So, just a little bit more complicated. You know how it is. That's what we do here. If it's not more complicated, then what is the point? It's not more complicated, then what is the frickin' point? We don't need you. Though I do like the braided cable design that I kind of had before. Or not the braided cable, the, well, that and also the just straightforward cable, which was this one with no, like, normal output. Because here are all the splines currently in the case. And then they split. And then they split. Oh, that looks like matrix code. But the problem is, since I didn't set it up in the way that I should have, it, oh, that is funny. Since I didn't set it up in the way that I should have, when they rotate, since the original spline is like, I don't know, like 2 meters off from the end points here. Actually, I could maybe subtract, just to make it, you know, the tiniest bit better. I subtract, 0.5 from that. Add 0.5? Oh, right, yeah. Wait, I took the ID, and I forgot how many IDs there are. There are 128. So if I take that, divide by 2, that should be 64. Subtract? Oh, no, wait. No, here it would be 20. Subtract? Nope, nope. I'm freaking myself out once more. I don't know when to quit. So here, this will just give us a value between 0 and 1. Because, again, it's, the value is the value. Oh. I need... Oh, no, I still need to subtract 0.5 from it. Or no, in this case, add, because the way I set it up, I'm a genius. I'm a genius. There we go. So now it doesn't have the horrendous offsets, but it will become more and more inaccurate as time goes on. Freak yourself out, you're freaking me out. I assumed that was implied. Like, with my brain going a million miles a minute, for people who aren't inside my brain, they can't see what I'm seeing, so they are probably entirely lost at this time. Which I apologize for. Anyway. Yeah, I know I go too fast, but then again, this took 3 hours to get it to this point in time. So yeah, that's one version of it. Oh, that, you know, that's gonna look really cool. You just have that and then split, and then it keeps going. Oh, that's gonna look good. Okay, let's disconnect this version from that version. What needs to be renamed? Okay, so this is mesh curve. Mesh curve. Those are labeled to resample curve, which I could lower this to whatever value I want to speed things up, but then again with the braid kind of thing, it should be fine. This will be offset curve. There we go. And I could again add in some animation to the actual geometry because it's already being recalculated every single frame. So either way I slice it, I could make it better. So this is straight, and this is random. Straight and random. Well, it's not necessarily straight, it's just ordered. Ordered, and this is random. Yep. And then I will make it so that it's not dependent on being close to another thing. There we go. This took way too long. Okay. What'd I break this time? Oh no, it's random. Okay, that explains that part. So I just want to see. I'm going to save it. With the different colors. What if we change this to be a little more? Yep. Computer building enthusiasts will be all over this. Totally. Or, no, that's their worst nightmare. Those cables splitting again and again. Which, yeah, okay. I should have a variant. Ha 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 ha, Loki reference. I should have a variant of this where it's just a straight curve. Again, this is the visuals. Visuals, and this is the sim. Curve sim. Go, let's change this to green once more. So with the curve sim, I'm just going to make it a straight line, just for kicks. There we go. So now if we watch this on a straight piece of fabric, or no, not fabric. Whoa, what happened? Oh, yep, too big. I just need to make it so that's the right length. Actually, yeah, why did it freak out like that? I resampled it. It should be the correct size. Went to half of its length, so 0.1. I need to not save this version. I need to consciously remind myself not to save this one. Yeah, why did do that? Okay, let's rewind. If it doesn't work, I'll figure that out. Off stream. Okay. Off stream. That sounds good. Oh, what did I mess up? Sim. Oh no, it's this problem again. Shoot. What'd I do wrong? It's not caching anymore. Come on. Don't break on me now. Huh, geonodes are broken. Sims are broken. Okay, turn cache off. What's its problem? It's acting as if there's no input geometry, even though they're clearly... I broke the sim. I broke the sim. I wish... There's no cache. Just from Control-Zing it? How did I break it? Okay, busy screen, real quick. I'm going to open up the file again. Just to make sure that I either had the right version. Okay, yep, that version's good. Okay. Remove the broken version. Okay. We're back in business. There we go. Okay. here we go. So we're back here. Shader functional. Yeah, I saved it right after I did that part, so we're in the clear. Let's set it back to the good version. I'll just collapse that. This will be radius, I guess. Yeah, radius. So here we have that. The main one, then they split, then they split, then they split, then they split. And you know, I could have the radius play into this. In theory. Oh, and it keeps on splitting, even though I did not account for that. So yeah, I could just keep duplicating it. 128, 256. So yeah, it's a little more laggy. But then again, I did decrease the resolution there. So it should be dealing with it fairly well. So I could just have it keep splitting again and again and again and again and again and again. Words. There we go. But I think that's... Did I break the sim? Okay, no, it's still good. Sim good? Sim good. Alright, thank you all for watching. This was a good project. Let me read the chat again. Okay, people had to go because it was like morning where they are. Yep. I like the live streams because you really have a real idea how to solve problems. The edited ones seem like no problems arise. Fair enough. He gets out of his comfort zone, forcing Blender to make it layer-based. Well, with layers, they're independent of each other. That's more of what I was thinking. Also, what is my... Where's the... It's at 1,000,000. Let me set this to be 500,000. Yeah, that's 500,000. It would be nice to have the comments in there, just to easily delineate, or not delineate, differentiate. Words, words, words. Okay. So now we have that. There's the ambient... Here, let me label this. Ambient energy. Energy. We don't really need the noise in this one, but I'm going to keep it, maybe make it a bit larger. Just for kicks. Then I could also input the Fresnel, I could also input the kind of radius. I could do a lot of, oh wait, I should implement the radius. So in geometry nodes, yeah, this value here I could say is our kind of radius. Not really necessary, but I'll have it just be R for radius. And if I store this value, then I could say, hey, the ones on the outside, don't be quite as bright. Don't be quite as bright. And I could also I could store the position before the offset, and that would give me a lot more flexibility. I could just get the length between the current position and the other one, but future-proofing. Let's just have R because that is readily available. So see, we can now get the ones that are further on the outside versus the ones that are on the inside. Yeah. I should store the location before the offset so that I can get this in a bit of a better way. Yeah, there's that. So I can just use a map range to make that more or less powerful. So let me do that real quick. The last little bit. Map range value. Plug this into here. As the last little part. Oh wait, we have 1 minute left until it's 3 hours and 40 minutes. I'm not doing that. Here we go. So there, outside. There we go. So there we go. We can see it being channeled through the center rather than everything else. Cool beans. All right. Yeah, that's a bit better of a gradient for all that. You can still see that very clearly. It's an internal energy, not an external one. And maybe I need to make it just a little more apparent. Maybe I need to use the power node again. Yeah, I can do that, but that's good enough. Put that into a frame, put this here. Thank you all for watching. I will see you all next time. Have a good one. Sorry this one took so long. Alright. Have a good night.